Hi there, and welcome to today's class. For today, we try to proceed from where we stopped in the last class. Last class, we tried to consider system of forces, right? Last class, we did the introduction to system of forces, and we said under this concept, there are four cases. So last class, we did case 1 and case 2, right? So for today, we'll be considering case 3 and case 4, right? So when it comes to case 1, that's when we talk about forces acting along x-axis. When it comes to case 2, we talk about what? Forces are acting along y-axis. So let's consider case 3. Forces acting perpendicularly. Case 3, please. Case 3. Case 3. Forces acting perpendicularly. Right? Let's consider forces acting perpendicularly, right? So this concept here, this one here, will take us to what we called resultant force, right? Resultant force. Look up. Let me show you something. Um, to consider force acting perpendicularly, let's say I have a force F1, as in this case, and I have a force F2, as in this case. They are acting perpendicularly, like this at 90 degrees. That's the concept. So what would be my net force here, right? You know, we said net force is equals to F1 plus F2. Now, in this case, what about our net force? Our net force is simply the line that will pass through this point here. So this call here F net, right? For instance, now from here now, to find my value for F net, I can infer something from here. The concept of Pythagoras theorem, that becomes F net squared. I'll have F net squared is equal to opposite squared plus adjacent squared, or perhaps adjacent squared plus opposite squared, anyone. So call F1 squared plus F2 squared. From here, if this square comes here, it becomes square root. So I'll have that my F net is equal to the square root of F1 squared plus F2 squared. Now look up this. This one now, this formula here is formula used for calculating resultant force, right? So now, in other words, I just show you the proof the way it is. But the correct sense of this now becomes change this F net to R. So it becomes R is equal to the square root of F1 squared plus F2 squared. Why do I change this to R? The concept is what? The idea of resultant forces. Let's define resultant force. Let's discuss resultant force a little bit. What is resultant force? A resultant force is simply a single force that can replace two or more forces and still produce the same effect as the other forces. Look at it here. I'm having F1 and F2, two forces, but a single force there will represent the two of them and still produce the same effect as the two of them. So that will give us the idea of what resultant force. So let's say I am person A, this is person B here. So there's a kind of force that will combine the two of us together. So let's say, okay. Let's say, for instance, this is person A, this is person B here, such that if me and this guy combine, let's say our weight or perhaps our power is 50 50 Newton per se, right? Our force that we have is 50 Newton, right? And there will be, let's say another guy will come. Let's say person C comes, and person C combine person A and person B together, such that person C can bear or perhaps can carry the weight of person A and person B. That's the idea of what resultant force, right? A single force that can replace two or more forces and still produce the same effect as the other forces, right? So that's like the definition for resultant force, and is represented by capital letter R. That's R. So mathematically, R is equal to square root of f1 squared plus f2 squared, as in this case. Now look up, why is it f1 squared, why is it f2 squared? Because I'm having just one force acting along what, y-axis, and I have only one force acting along x-axis. What of if I have many forces acting along x-axis and also many forces acting along y-axis in a question? Will you still use this formula? No. You use what? R is equal to the square root of summation of f of x squared plus summation of what? F of y squared. These people here are still the same thing, but the idea changes. What's the idea? The idea is that for this one here, I'm just having just one force. So when you're having just one force along x and y, just one forces, you can apply this one here. But if I have more forces along x, more forces along y, the idea changes. Just add a what? A summation. That is, you first calculate for the addition of all the forces acting along x-axis. Then you square it. Then this one is simply the summation, the addition of all forces acting along y-axis, please. That's the condition behind resultant force, right? So let's take a question, right? Let's take a question, for instance. Um, let's take a question. Let's take a question. Okay, before that, before taking a question, right? Okay. Before taking a question, let's consider case 4. Then we use the idea to solve um other questions, right? Yes, let's take case 4, right? Case 4. All right. Also, before I move on to case 4, also I can still write this one as saying this one can still be written as r is equal to the square root of what? F of x squared plus what? F of y squared. This one here and this one here are the same thing, right? F1 is force acting along x-axis. F2, see, look up, F2. See, F2. Sorry. Okay. F1 is the force acting along y-axis, Abby. F2 is the force acting along what? X-axis. So F1, which is this one here, y-axis is for this. F2, which is horizontal, x-axis is for this. So you can just place them together. Or what have you? I can choose to say F2 before F1. It's still correct. I can say Fy squared before Fx squared. It's still the same thing. It's still correct. That's the idea behind resultant force. Let's consider case 4, please. Case 4. Case 4 will take us to what we called resolution of forces, right? Resolution of forces. I'll take my time to break this concept down because it's very quite challenging for most people, right? So just understand the concept behind whenever a force acts perpendicularly, you apply the idea of what resultant force. And we said it's simply is a single force that can replace two or more forces, right? So, and the formula is given by R is equals to the square root of summation of f of x plus summation of f of y. That's the concept, right? So that's for, but this is let's say this is the real formula here, because you can apply this one when you have your questions can come in. The question will be given in exam. Your lecturer will be giving you cannot just be just one forces. You have more than one forces, right? So in that case here, you can't use these two. You use this one. So this is like the correct formula to apply when you have a question, right? So these ones here are not for this ones here are for junior secondary school, right? But this one here, this is actually for this is people advanced, right? You use this concept, this one here, because your question can't just give you one force. You are mature than giving you one force. They'll give you more forces, so you can't apply this two. You apply this one. But I'm trying to tell you that this one and this are the same thing. Just as the change in definition, f of x and f of f1, f1 and f of y are the same thing. Fx and f2 are the same thing, please. That's the concept. Let's go back case 3. Case 3 says that forces acting at an angle. Forces acting at an angle. All right. when we have forces, right? When forces are acting at an angle, what's I there? What do you infer from it? It's quite simple, right? Let's consider something, please. Look up. If I have look up, oh, if I have a force such as this, let's say I have my okay, I have this. Let me call this F1. Let me call this F2, such that they are acting at an angle theta, right? So the idea here is quite simple. If you are given a question such that that question you are given, your forces are inclined at an angle, your task there is what convert that angle into what they convert the stuff, the inclined F1 and F2 into what vertical and horizontal component. You convert the question given in angle to what to vertical and what horizontal component. That will take us to what resolution of forces, right? So let's discuss something important. Resolution of forces. Let's discuss resolution of forces. Definition. Resolution of forces is simply resolution of forces is simply the ability to convert forces at an angle to vertical and horizontal component. That's like definition for resolution of forces, right? If you're given forces in terms of angle, your task there is what convert it to what a vertical and horizontal component. That's the concept. Look at this one here. Look at this here. This one. Let's convert this guy here to vertical and horizontal component. I'm having something of this nature. Look up, observe. This is F1, right? This is F2, right? So the task says it's quite simple. Theta, right? Let me call it theta. Or perhaps let me just call this one here F. Let me call here F, right? Let's call here F. I say, just call it F in this case. To convert this one to vertical and horizontal component is quite simple. What's the first task? This is the force inclined at an angle. I want to convert this force inclined at an angle into what? Vertical and horizontal components. Observe that I'm having this one here, right? So I'll bring out this one, this sketch, this one and this one outside, because my arrow is going outward because the force is going outward. So the arrow will what? Go outward. Yeah. Now observe that this angle is lying on this one here. So this one is this one here. So anywhere the angle is sleeping on or perhaps lying on will be the cos. Note that, please. That becomes, this is F. This one becomes F, right? Then the angle is lying on this becomes F cos theta, right? So the other one becomes F sine theta automatically. That's the concept. These are to resolve forces at an angle to what? Vertical and horizontal component. Wherever your angle is lying becomes a cos. Look up. Let's try to convert this here to vertical and horizontal component. Let's say I have perhaps okay. Let's say I have a coordinate system, as in this case I have a force here, right? Let me call it 30 degrees. I want to convert this one here. Convert this one here to, so I have angle here. Let's say this is F1, this is F2 here. Let me call here 60 degrees. Look at this one here. My first task is to convert this place here to for question like this. For a question like this, they'll ask you to find the resultant force in this coordinates a coplanar concurrent force here. Coplanar concurrent force. So has to find the resultant force for something like this of this nature. But first things first, I want to show you how to resolve forces into vertical and horizontal component. Look at this one here. To convert this force here into vertical and horizontal component, I'm seeing this force acting outward, and this is the boundary of this one here. I'll draw out the boundary this way, as in this case. Observe this. When you are done, the angle is inclined to this one here, and this is this one here. So it becomes this become cos. Start with the first. That be f1 next up cos 30 degrees. I'm done with this. So without stress, it becomes what? F1. This becomes sine 30 degrees. I've resolved this. I've resolved it. Let's resolve this one here. For this one here, it's going outward. My restriction is just from here to here. So draw a diagram from here to here. I want to convert this inclined angle here forces to what? Vertical and horizontal component. Now, this is angle is lying on this. The angle is lying on this one here, and this one here is this one becomes cos. Becomes f2 cos 60 degree. So automatically this becomes what the f2 sine cos please. Sorry, sine please, sine 60 degree. This is how to resolve forces into vertical and horizontal components, please. Try to understand this concept, right? Try to understand the concept. It's very important, right, when it comes to system of forces. So let me show you some. Let me just summarize what I've said since morning. In your examination questions, when you be given something like this, so in this case here, I'm having more forces. Look at this. Look for this one now. I'm having horizontal. Look up. I'm having horizontal, vertical, horizontal, vertical. If I'm given an angle here again and a force, I'll be having like 6 horizontal forces and 6 vertical forces. True or false? True. In that case here, if I'm trying to find the resultant force, I'll apply this formula here, because I'm having more of f of x here. Like this is these are forces acting on x axis, f of x, right? I have more of f of x here and more f of y. So to find resultant forces, just recall this formula and you are done. And note that in most questions you'll be asked to find resultant forces and the angle, like you'll be told to find the magnitude and direction. Okay. To understand this concept more better, I will try to do example in the next class, right, on this stuff here, right? So next class, try to do more example in the next class on this stuff here. But note something, please. In case you are told to find the magnitude and the direction, right, of something of this nature, to find the direction, that's direction is simply the angle. The magnitude there is just the value in Newton, right, in the value. So to find it, just note we make use of all these notes, all these concepts in the next class when we're solving examples. Note that when I thought to find the angle in a question, when it comes to resultant forces, the angle becomes tan theta is equal to summation v over summation h. Or better still, you can say that tan theta is equal to summation of what? F of y over summation of what? F of x. Summation of v, it means the addition of vertical component. You see the same thing as what? Summation of f of y, right? So this one here is similar to this one. So what have you there? So when it comes to resultant forces, it's like it's very important to know to find the angle, and there's no how. They'll tell you to find the magnitude and direction, right? So they'll give you a concurrent coplanar system, right? They'll give you a question. Now that question will contain many forces acting along x and y axis. So you'll be asked to find the resultant force, which you apply this formula, and you'll be asked to find the angle. So to find the angle there, you use this formula here, right? So the summation, after getting your f of x and f of y, to get the angle, just say tan theta is equal to your value for f of y. You put it up, divided by value for f of x. Then you have your angle. See you in the next class. Next class, we'll try to consider much more example to further explain all what we're just saying here. See you in the next class.